Hello again, everyone. This is your friend Kent C. Dodds, and I am joined by Dan Abramov.
Hi there.
and we are super excited. This is the second show that Dan has been on this show that I've not actually released yet. So, but all of you listening, I have now. So, so there you go. Yeah, so we're going to be, last time we talked about hooks and really awesome conversation. If you haven't had a chance to listen to that, I suggest that you do. Now we're going to be talking about the future of React and some of the things that React is planning. It's React is not a done thing. There are still things to be improved and done here. And there are several projects that are at different stages of development right now that maybe we've heard of a lot, maybe we haven't heard of as much. And I want to dive into some of those things and also like think more broadly, what is the overarching goal? What's the end game for React? What are we really striving for here? So to get into that, and I guess I just want to kind of start on when you discover that there is something missing in React. What is the process to kind of decide not only that this is a thing that should be solved by React or should be changed in React to solve this problem, but also determine what the solution should be? What's that process there?
Yeah. I think a lot of it is just like listening and reading. So we get a lot of feedback from everywhere, like from GitHub, from Twitter, from like internally, obviously. Like we have a lot of people using React at Facebook for like different kinds of products on different platforms with different constraints. And so I think if you respond to like questions and if you look at the problems people run into and the things that bother them, I think eventually, or like even like if you look at the ecosystem solutions where people can try to plug some hole in React or like work around something that React does that they don't want it to do. I think eventually you just started noticing common themes between them. So it may be that React is missing something, or that React is like doing something that it shouldn't be doing, or that some solution is not optimal. And I think in many cases it's tempting to, like if I were personally designing a library, I would probably just like try to do like the smallest possible kind of fix. So like I would add some API. I don't know, like imagine like data fetching, right? So like you can see that like all React components need to do data fetching, but they also need to like manage loading states. So maybe like should I just like build some kind of like load-in state manager into a library? And like if I was personally designing a library, maybe that's what I would do. But luckily, I I don't design React. At least like I help, but like I work in a team. And I think the approach that the team has been taken to those things, especially Sebastian. So Sebastian Markboge, he's kind of our like a visionary for like React, and like he has all kinds of funny ideas, but his way of working is very interesting. So I think what he does is he listens to a lot of like feedback and what people ask for, but then he takes a step back and he's like, well, why does this problem exist in the first place? And I mean, it's kind of natural. So like you want to do a step back, like when you're thinking about the solutions. But what's interesting about Sebastian is that he goes like 10 step backs or like 50 steps back.
Like this
And
problem
he's like,
exists because of React. Like,
yeah, but like it's, I mean, it is like trade-offs. Like sometimes we do introduce problems. So like React ensures that the render result is consistent between mounts and updates, but that can make it more difficult to do animations. So like now we have to solve the animation problem somehow. And so it's like it's always a trade-off, like which problem is worse or like
Mm.
which problem is more common. And then sometimes you create a new problem and then you have to like plug it too. And eventually like you solve enough cases that it's like it's good enough, like pretty good. And then you have like escape hatches for like the cases that somehow don't fit that.
Mm.
But I think what's interesting about his way of thinking is that he backtracks very far, and sometimes he notices that like everybody makes the same assumption, and he's like, no, but why do we even like think of it that way? Why don't we like think about it differently? And then that can unlock a whole new path for a solution that is like completely different than what anybody else tried. And I think like that's really the spark. So like that's the first thing, is that there, like for every project that we do, there's got to be some vision. There's got to be some spark that is like, wait, what if we like try this? Could it solve a whole class of problems? And so after that, we like usually then it just goes into backlog, and like maybe we do this in a month, maybe we do this in 6 months, maybe we do this in 2 years. Like
Mm.
we have this funny page with like a list of code names. There's like for projects that don't really exist. That are like aspirational. So like some of them are not even like possible today. But it's like a bank of these like ideas and these insights of like, wouldn't it be cool if we tried this? And then at some point it feels like the place and time is right. It's like maybe we just like, this has to be fixed because like some other issue made it worse, and now so like hooks are a good example of that actually. We had the legacy context API, the one with context type before create context. So there was like context types and child context types, not context type, but context types. That's the legacy one. Like consumer is not legacy. That's all part of the new
That's
one.
the new stuff.
Right, but like we had this legacy API that was pretty broken. Like it was not documented at first. There were like warnings everywhere saying don't use it. It's experimental. It's gonna like fall away. But then it was clearly like needed. So everybody used it anyway because like the feature itself was so valuable, even if it was half broken. And so eventually, like we realized we can't fix this existing API, but we can make a new one that solves the same problem in a better way that actually works. And so that's what the new context API was. What we released it with this provider-consumer API pair, where consumer is a render prop. Like not because the render props are like fashionable, but just because like the API design itself like needed to be composable.
Mm-hmm.
And so we kind of relied on render prop to do that. But that kind of made things worse because now that you use the render props everywhere, like your tree is just like it's hard to read what's going on, and you can't access it from a life cycle. So Sebastian has this like saying, like, make it worse to make it better. So I think that's what happened with the context API. We knew we needed to solve that problem. We solved it. The solution itself introduced another problem, and the pain from it was so annoying that it kind of led to hooks. So like it led, which like solved other problems for us. So it's just sometimes you need enough pressure on some pain point where you're like, okay, actually we got to solve this now, and like we have something that replaces it. So I think that's the path from like the inception of idea to the point where you're like, okay, we got to make this happen, and like we got to at least try it. And then we try it, and like we dogfood it at Facebook. We see if that even works. So that process can take like months, could take a year. But eventually the project, like we feel when it's good enough. So we started by focusing on one use case. We usually find like one team that wants something, and we work closely with that specific team, and like we make sure that the API or like the solution or whatever satisfies their particular use case. And usually that gives us like first round of feedback is like, this doesn't work, this is bad, like this is slow. And so we iterate on it, and eventually they're happy. And then we are ready to kind of take on more like client teams. So like maybe we have like 2 or 3 teams at Facebook using something, and eventually we kind of roll it out internally and more people use it. And so if once we satisfy like 3 or 4 teams, we feel like the API is generic enough and like we also know it better, we like feel more confident about it. And that's when we release it to open source. And that also gives us some feedback like in alphas and so on, and that can lead to some changes. But it's like this gradual like graduation process of like focusing on one customer, then a few more, and then doing this broad like beta testing and then rolling it out. And that's how we release projects.
No, that's cool. One of the things that I take a great deal of comfort in is knowing that Facebook has 50,000 or more React components, and so
A
anytime
lot
you,
more. I think it's like 90,000
oh
now.
my goodness, wow, my information is out of date. Yeah, but just knowing that there's such a huge amount of React components there, that nothing could possibly happen to React that would make it so hard for me to upgrade, because Facebook needs to make it easy to migrate or upgrade or whatever, as well. So we're never going to have a here's the new framework situation with React, which is cool. That said, there are cool things that are kind of opt-in that we can get into, and whether it's like when we had React Fiber, that wasn't really an opt-in. It was more like this thing should, all of your existing stuff should hopefully work. And then we have hooks, and that's this new opt-in feature. All of your stuff continues to work, but now you can use this new feature. I know that there's this project React Fire, which is unfortunate naming with React Fiber, but there you go. But
So that's kind of intentional because like you're not supposed to use those names. Those are just code names. So like the point of those code names in a large part is because we realized that giving them concrete names like React, like this thing, it actually can cause problems because now you're kind of hung up on this idea of, oh, like this project is like this specific thing. Whereas actually like you don't really know yet until you like try to implement it and dogfood it and so on. And so we found that code names are really useful because they give us something abstract that we don't have to attach a very specific meaning to, and that kind of makes it more obvious when the meaning needs to change. And then eventually when we feel like we settled on what this project really does, the name is just obvious how to call it. And then that's when we give it like a name and we ship it, and then it's just React. So it's not a project anymore like React Fire or anything. Eventually, if it happens, it's just going to be React. And it's the same with Fiber. It's just React 16.
Yep, that makes a lot of sense. So let's talk about some of these specific projects that you're working on. And I think that's an important insight that you mentioned too, because some of these things, in my mind at least, they're really interrelated. Like we have suspense, we have concurrent mode, we have the new server rendering stuff. I think React Fire is kind of in a class of its own with React DOM specific changes. But yeah, can you talk with us a little bit about some of these projects that you have in flight and what the goals are a little bit, and maybe start with what stage it's in so we have a good idea of expectations.
Yeah. So I think from the ones I mentioned, so suspense is a difficult one because it's a bit difficult to talk about because it's going to be shipped in stages. And so the first stage, like when like a rocket takes off and then it's like
yeah.
So like we kind of did that already with 16.6 release. So that includes the suspense component and the lazy wrapper, which is we like brand it as suspense for code splitting. But that's just like one possible way to use suspense. So the idea of suspense is it's declarative loading states. That's what it is. That's really all it is. So it's ability for a React component to say, hey, like I'm not ready to render. I need some whatever. Like I need to wait for something, which could be like wait for code. It could be wait for image like be loaded and decoded. It could be like wait for like, I don't know, some data call or whatever. Like we don't want to build data fetching in React, but we're building this
primitive,
yeah, like a way for component to say that it needs something, it's not ready. Because building that into React can actually unlock some very interesting features. And so one of those features that it unlocks is declarative loading states. So now that when we try to render a tree, we're like, oh, this thing is not ready. So what we can do is we can say, okay, we need to show a spinner. And so usually the way you do that is that you put right into that component, you put like if is loading, then something, but then you have to put that logic into like every place where you want to show a spinner. And so, but if you think about it, like how do we handle errors? So like errors also can happen everywhere, but we don't put like error handling logic into every single function. So instead we're like, oh, here's like a checkpoint, here's the place where we're ready to handle errors, and then if anything below like throws, we want to catch it. So that's like try catch is like this model of letting some code like run, but then you can catch it, and you can have nested try catches. So that gives you the granularity. So like if some inner code thinks I'm going to run this like file system call and then catch an error, and I want to handle it in my own way, then you can do it. And React 16 applied the same philosophy to error handling with error boundaries. So with error boundaries, like out from 16, if anywhere in the component, like a component throws, you could put like a shim, like an error boundary somewhere above it on the tree that says, if something in my tree fails, I'm going to be like fault tolerant. I'm going to show you some like error message, which can be like granular. So you can put it like around specific elements, or you could like put it at the top level. Usually you want some granularity. So like you put it close to major UI elements. There was actually a great post by Brandon Dale on his blog about like how to use error boundaries. So check that out. But anyway, the same philosophy can be applied to loading states as well. So you can say like we're rendering something, then something is not ready, and then like if maybe it's like an autocomplete widget, and it's silly to put a spinner into the autocomplete widget because like the whole form is not really useful if the autocomplete widget is not useful. So what people usually do is they just don't do code split in there because it's just too annoying to like handle. But if we could put a loading state above, like around the whole form, and say, if anything below is waiting for something, just show the spinner. And you could have like nested ones. So that's what suspense really is. But for now, we only allow to use it for lazy loading components and code splitting. But the end game with suspense is that you can use it for everything. And then you could use like an image component that suspends until the image is ready. And so you could make sure that like if you have an emoji picker, when you pull it out, it doesn't like emojis don't pop in one by one, but they just, and that's really like the goal of the suspense API is because it's now declarative, we can understand where things suspend, and we can show the right placeholder for that. So that's one project, but suspense is for data fetching specifically. There are like a bunch of unanswered questions, and we're still figuring those out. So like it's not going to ship in the next couple of months. Hopefully this year, I don't know yet. We'll see. It's like very active research project right now. And so the other one you mentioned is concurrent mode, and I think concurrent mode is the big picture for concurrent mode is a lot of stuff kind of ties in together there, but really it's about, so a part of it is about non-blocking rendering. So currently the way React works is that if there is an update, React will just like go ahead, render everything, flush it, and like be done with it. But on large component trees, that means that while React is kind of walking the tree and doing something and like creating DOM nodes, it's like the main thread is busy, you can't handle any events. Even if the event that happened, like if I delete it, like if I press some button, like I don't want to see this tab anymore. but this tab already started rendering, so you can't switch away from it. Like it's gotta finish rendering, so it's blocked. And so what we want to have in React is that to make rendering non-blocking, so that React can start doing something, but then if you're like, oh, I want to do something else, there is no need to continue. We can just throw that away.
Mm-hmm.
And I think it's important to point out that this is not just like some workaround for like slow performance of React or something like this. Even if you have like some kind of reactivity system that like magically tracks like which thing has changed and like what is the minimal update, like in a lot of apps, actually the updates are they're not like granular, they are very coarse. So like you switch from one page to another, there's no like 1,000 bindings to update. It's like you move away one block and then you render a whole new tree, and you can't make that faster if like you're already like you got to create those DOM nodes and you got to make those data fetches and stuff like this. And so the question is, can we still make it more efficient and more optimal, and to be able to like pause in between, and if the user wants to do something different, we shouldn't like stall the browser.
Mm-hmm.
So that's really the big picture behind concurrent mode, is that making this React do this by default, because you can kind of like make your own like ref loop with request animation frame, and then try to be smart about like updates and like idle callbacks. But then it's very hard to orchestrate by yourself,
Mm-hmm.
because like if you try to like progressively load components by yourself without blocking, you're probably going to see intermediate states on the screen. So you're going to see like this tree appearing, like if you have like a bunch of comments and you try not to block rendering, you might be like inserting them in idle timeouts. And if you load the page, like all the things like jump around, and it's really janky.
Yeah.
It's not just like UI janky, but it causes reflows and like layouts and style recalculation. So it's actually like it's worse for performance to like keep doing this.
Mm-hmm.
So what I want to do instead is you want to make the process of preparation, all of these things, non-blocking, but then you want to block when you like put it into DOM, which hopefully should be like an atomic operation,
right?
just like
Pretty fast.
apply the update.
Mm-hmm.
Right. So that's really what concurrent mode does. Is the idea is that you wouldn't even have to like manage it, except sometimes you would have to like give hints to React about which update is urgent and which update can wait a little bit. And some patterns are a little bit different. So like if you want to take advantage of this of this behavior, you might want to opt in a few places. But the general idea is that you write components in the same way, but React is just smart about not blocking the browser and instead working together with the browser to give you a good user experience, regardless of how fast your computer is. And this is something you can't even like achieve with debouncing. So one common solution is, okay, like maybe you have an input and you have like a list of items, and maybe it's expensive to like re-render that list, so you just debounce, you wait for the input to stop typing, and then you update. And so that's the naive solution. That's how you avoid like jank when typing.
Yeah, not a super user experience, but at least it's not janky.
Yeah, but like it is actually. So it is janky if you type something, happen to pause for a second, it starts doing something, then you're like, you want to delete? It doesn't delete. It's like it's already in the process. So there was this like random hiccups where you try to do something and then like it doesn't work because the debounced function kicked in and now you're blocked. So really what we want to do is and also the other problem is that on a fast computer, you're unnecessarily waiting for that whole second or like whatever your debouncing interval is.
Mm-hmm.
So in concurrent mode, the idea is that if your computer is fast enough, you're going to get results like as soon as you type. But then if it's slow, like you're not going to block the type, and the results are just going to lag behind a little bit.
Mm-hmm. Yeah, that's awesome. I think this has interesting implications on our existing code, because like where with suspense, that's kind of a new feature. You opt into it by using it. But concurrent mode, if you aren't well, I want to say if you're not careful, but it's basically if you're not idiomatic, then you can run into some problems with concurrent mode, like realizing that yes, my function component was called, but it actually may not have been rendered yet, and so it's going to be called again. And so if you're doing some side effects in there or something, this non-idiomatic stuff, then you could actually run into some problems. Do you want to talk a little bit about that as well?
Yeah, I think the most important, like I think it's harder to do this mistake with like function components than
Mm,
classes. And that was also a big motivation for hooks. It's just that a lot of those patterns kind of, it's just harder to mess them up with hooks than it is with classes.
mhm,
Um, but even with classes, like you're not supposed to do side effects in render. Like that was pretty much like day one
mhm,
React 101. But like yeah, sometimes people do. But I think the biggest change that concurrent mode brings in this sense is that just because a render was called doesn't mean that like the results of it will be flashed
mhm,
immediately. Which is always like it's already the case with batching, right? So
mhm,
like uh, when it calls that state, it doesn't like in event handler your this.state doesn't update immediately. And concurrent mode is kind of a stronger version of that, which is like actually like more things are batched by default.
mhm,
Um, but what essentially this means is that if like even if your component got rendered, the render may get interrupted. So like we may walk to a component, it rendered, like it gave us some children, then we walk into children, and then the user like typed something else, and maybe this whole tree is now is irrelevant. So we'll just throw it away. So this is why like if you assume that the rendering necessarily means the component like will be mounted or like updated, that assumption might be violated. But
mhm.
then even in classes, if you use life cycles in the intended way, so like component did mount and component did update are guaranteed to be flashed after it's committed.
Mhm,
So like those are safe places to do side effects because by that time the DOM is guaranteed to be there. But
mhm.
like render is more kind of ephemeral, I guess.
Right. Yeah, and the same would apply to use effect as well.
Right.
Yeah.
Right. So like don't do side effects in like function itself, do it in use effect.
Mhm.
Which is like more obvious, I think, because well, render function is just supposed to return something. Why would you like do side effect in it?
Yeah, well, I mean, I have been known to do side effects in render before. So yeah, and there are if you're doing that, there's a better way to do what you're doing, I guess is what we're suggesting. And it's more idiomatic as well. So it's not typical that people are going to run into these kinds of problems, but it's definitely something to be aware of. So what other we don't have a ton of time left, but what other projects are you currently working on in the React team? What other things are you excited about?
So I, for the past few months, I've been mostly working on like kind of helping, well, not fix hooks, but just like post-release maintenance. So like fixing bugs and hooks, writing documentation. I made this ESLint plugin called Exhaustive Depths.
It's
Sorry,
so
it's
good. It's so good. It's ESLint plugin React hooks. So good.
yeah, and the rule is exhaustive depths. So this is the thing to help you kind of build the right mental model around, like if you specify use effect or use callback dependencies argument, this thing will tell you like when you're forgetting some of them, and uh, it's just something. It's not even like so much the rule itself that helps. That just it helps you understand how to think about them, and then you can see violations yourself. And I think like most of the work for me was not even like writing the intro in the past month, but it just figuring out how to think about those patterns and like what the best practices are. And I think like we have a decent idea of what those are, and those are like encoded into the rule itself. So I've been focusing on that, but I think I like personally I'm most excited about like concurrent mode and suspense playing together. It's still like there are still so many unsolved problems there, but it also ties into the new server render that Sebastian started working on.
Mm,
That is streaming, so like you would be able to do asynchronous like data fetching on the server, and then kind of stream that with the data on the client. And then
Oh my
there's
God. Okay, I don't. Let's just make sure that people listening understand the impact of what it is that you just said. That is so cool. Yeah, will you go ahead and continue? But I just want, if you were like coding up while you're listening to this podcast, I want you to stop because this is really, really awesome.
so the I think the other pretty out there thing about it is that so Sebastian's working on partial hydration, which is again like this idea. Like if you take a step back, the way server rendering works is not very optimal, right? So like currently you if you use Apollo, which does this double render, you might not notice it, but like in practice, render on the server in React currently is synchronous.
Mm-hmm.
So you have to do some like convoluted way to like gather your data dependencies, and then you gotta send it all as HTML. Even if you use the Node Stream API, you're still technically like sending
You have to have
like
HTML up
you
front.
can't pause
Yeah.
it. Yeah. And on the client, you're gonna get the whole HTML first, and then you're gonna get all JS, and then you're gonna like hydrate it all, which is like render your whole app,
Mm-hmm.
and then it comes interactive. So that's not really like if you take a step back and like what is the like ideal way you want to do it. You want to flash first of all you want to flash HTML, like you want to do data fetching on the server because the latency is so low.
Mm-hmm.
So you want to flash like you want to flash the page in chunks. So maybe you flash the like the shell of the page first, like the layout, the sidebar or footer, stuff like this, and maybe in the middle like there's this like some kind of shimmer or some loading thing. So you can flash that as HTML and it appears immediately. And then you kind of keep streaming back like more things as they like as you resolve the data dependencies on the server, and you render those components and you stream them in together, like interleaved with the data that they need on the client and the code. And so you would be able to hydrate it progressively, like without loading, like you don't want to load all JS just to render like something. And so what you could do is you could like when the user starts interacting like with the button, but that button isn't hydrated yet. But now we know that like we need to hydrate this like the components with this like ancestor path first. So then that becomes a priority, and then if we get a if we get like a resource loading API, so this is still like a lot of this is in flux because it would work so much better with browser support, and like we're working closely with browser folks on this. So there are like standards proposals that would make it better. But like ideally we'd want to say that like, oh, this thing is important, like user interacted with it, give me that code like as fast as you can. And then the server could stream in that code and we could like hydrate that part of the tree while like the rest of the tree is not necessarily hydrated yet. Just like prioritized loading of everything. And then like suspense could work on the client as well. So it's a very like integrated picture. And I'm not telling you that, you know, that it's going to be available anytime soon. It's kind of like a longer term thing for like maybe at the end of this year we'll have something, and it's probably going to be a lot more opinionated than you're used to from React because it's just you can't integrate all of those things together if you don't have opinions on how to do certain things. So we'll see about how that plays out, but like the basic building blocks will be like we won't like hard code any specific like data fetch and implementation or anything like that. So it's more about like allowing other opinionated implementations like Next.js take full advantage of that underlying component model. And so yeah, those are like really, I think a lot of those things are really exciting at the way they like interplay together and kind of influence each other, and how you can combine them to like to do things automatically that you just like it was just too much work to do them manually before.
Yeah, wow, like I'm super stoked about that. So I don't do a whole lot of server rendering stuff myself. I use Gatsby and it does, you know, that magic stuff. But one thing that I have a question about with the server rendering specifically is it's my impression that React or Facebook doesn't actually use server rendering for in its major properties. Maybe it does for some things. I don't know. Maybe you can. I'm mostly curious if React doesn't use server rendering. What is the justifiable reason for Facebook to invest in that?
So I think for like for a long time, it was just like an open source thing. So we knew that a lot of people in the community care about it, and that it's kind of like a unique. For a while, it was like a thing unique to React, that React could even do
Mm-hmm.
this. And it seemed like we wanted to empower like other companies to invest into React to like be able to do this. So like the incentives were just that we thought that it's important, and we kind of pushed to work on this. But we're also like, we've experimented on and off with using server rendering more like at Facebook
Mm.
at different parts of timeline, and like um, we'll see how it works
Yeah,
out.
well, I imagine if you get something like what you were describing working, that would be a pretty compelling reason for a company like Facebook to work some of the infrastructure to make that a reality. So,
Yeah, I think like the like this idea with like chunks and chunk rendering is kind of influenced by the thing that we use in like in Hack and PHP, this pagelet architecture, which you can Google like pagelets Facebook or something like this and find the post from 2010 that like explains this architecture and why it makes sense. And while the Facebook website might not be like the best example because it's just vast, over complicated, like there's just so much stuff there. But that's like a topic for for another post. But the architecture itself is pretty solid,
Mm.
and we're trying to combine the things that we learned at Facebook about like doing complex server rendering in like Hack, with the things that we learned in the open source community from like projects like Next.js, Gatsby, and so on, and trying to find the best what is the most optimal thing that we could do.
That makes a lot of sense. Cool. So, there's also React Fire. We didn't really talk too much about it, and I'll just link people to the GitHub issue that you posted back in August about this. Um, but can you just give us an idea of where that is in the stage of development, and like when we might expect to start seeing some changes there?
So yeah, so the Fire thing is about modernizing React DOM bindings. So there's a lot of stuff in React DOM that is I wouldn't say like necessarily outdated, but just like some design decisions around the event system and around the attribute and property handling, around web component support, um, about like the way we where we bind to event listeners and stuff like this, is just like pretty old, and some of these are worth reconsidering. Um, as Sebastian said somewhere, that fire is not set in stone; it's more like lava. So it's like, don't take these specifics. So these are just like specific things that we kind of wanted to look into. Like these are known problems, like listed in that issue.
Mm-hmm.
Uh, but the project itself is like, we already prototyped a version of this, and like we find that it turned out that like some of the event code is actually solving real problems.
Mm.
And like if you try to remove it, then like a lot of stuff breaks, because like actually browsers are not as consistent as people might think.
Mm.
But it also gave us some new insights about, okay, so if we have this event system, and like if we think that it's actually valuable, which I think we're starting to think that it is valuable, and that it actually like solves a bunch of problems, then the problem is, okay, why does everyone pay for its weight when they're like not using all of those events, or if React doesn't even take full advantage of it? So like the vision for the event system was way broader than whatever like the lockdown version that we're kind of using
Mm.
today. And so the question is then, if we do want to keep that code around, can we make it, first of all, like more like easier to extract if you don't use it, and second, for people who actually care about handling events consistently across touch and stylus and mouse and all kinds of inputs, and like handling gestures like taps, spans, swipes, all this kind of stuff. So like if people do want a consistent API for this, what would that API look like, and can we kind of offer it as a opt-in thing that is like integrated with React and works really well with it? So that's the current exploration. It's just none of this is set in stone. Like all of what I've said might be like invalid tomorrow, but we're actually getting a little bit excited about the event system, like not the current one, but we could build a better one, and the things that it could enable that like are real problems that like product engineers run into every day.
Very cool. Yeah, I linked to that in the notes so people can take a look and dive in deeper. One thing that I'd asked on that issue that I'm kind of curious about is and related to another project, and I'm just curious about the status of this, is JSX version 2. Is that a thing that's being actively worked on? I know, like, I feel like I've seen that idea tossed around for several years already. So do you know what stage of development we're at for that?
I think it's in the stage of like it's not painful enough to be worth it yet. If it's like I don't know, like we could have come up with hooks and like not ship them for like a long while until like there were some more pressing concerns. I think it's kind of similar that we like some of these changes would be nice, but it's so much churn for the ecosystem that we need something that would like make it worth it, or some other kind of clean break that's like we can kind of attach it to. It doesn't seem like it's an important thing to do right now. But then, like, who knows? Maybe after we ship all of these features, we're like, okay, like maybe it's time to fix JSX. So we'll see.
Okay, cool. So to wrap us up a little bit, I'd like to ask, now that we have kind of an idea of some of the cool things coming up with React, there's been a history in the React community. React is a framework. React isn't a framework. But with some of these changes, it might start to feel like, React is really becoming a framework if it wasn't before, because now we are kind of handling data fetching and we're doing, server rendering and all of this stuff. Is React becoming bigger? Is it are we just going to put everything into React, and now we have the React CLI and we have these conventions that we follow, and is that the future for React, or what's the goal? What's the end game for React?
I don't find the distinction between a library and a framework very precise or helpful, but I think like in my mind, React has always and will be a library. I think of Next.js as a framework, and I think that in the like eventually we'd want to I think it's good when there is a library that is like the core, solves the core concerns, and then there is a framework that lets you leverage the library in the best, like in one possible opinionated way that is like pretty good, and like others can create other frameworks that leverage it. So I think that's the, like, in terms of what we put into React versus outside of React, like we don't want people to be stuck with like non-optimal solutions if someone could write a better one. So that's why we keep React itself pretty lean. But then when we think about like a lot of people use React as just like a view layer, but React hasn't ever really been a view layer, because the notion of a view is very
static.
Yeah, so people often mean by view it's just like a mapping between like some inputs and UI, but React has always been a UI library. It's like not an MVC library. It's not a web framework. It's a library for building user interfaces, regardless of your environment, regardless of like the broader, like maybe it influences your broader architecture, but it's always like it's also like its own thing, and it cares about this abstraction, a component. And so I think this is why React doesn't have its own routing or its own data fetching, because like those things are kind of external to this idea of a component. And like but then on the other hand, if we look at how people use React, you will notice that a lot of components like do data fetching, because like it's related, it's a UI concern in a way. And so it might be tempting to like say, oh, let's just add like get fetch, like let's just make like render like return a promise, or like add get fetch data to like render and so on. But this is like when Sebastian kind of takes like 10 steps back. And I think what we realize is that usually if something is related to UI, then you can split a task that people think of it as a single thing, like a data fetching. You just think, oh, data fetching, what could be like, or like routing. But it's actually like there's usually some lower level primitive that is related to the UI abstraction. So in case of components, it's like the ability to suspend rendering. So it's not that it doesn't matter what they wait for. Like, is it like data or code or an image or something else? Really, the language level almost, like React is not a language, but it kind of behaves a lot like a language. And the language level primitive here is that you want to say, I want to wait for this thing and then continue. And then React can be then smart about it and like, oh, like this component is waiting for something, but I can still render all of these components. And so it gives React unique flexibility to do things that you can't just do by like putting data fetching aside. So as an example, like maybe you switch a tab and you're gonna, like with concurrent mode, we can actually wait a little bit before like showing the spinner, but we can kick off like rendering of like header, footer, and like all of these different elements that are like static in a non-blocking way. But then some things might be waiting for data, and so they're suspended, and then they continue, and eventually when it's ready, we show the result. And if it's ready like fast enough, we don't even show the spinner. We just don't do the transition until the time, and like it's you can't really perceive the difference, so it feels like instant. So that's really the thing that you get by integrating those UI concerns, which is like waiting for things into the library, but then pulling out the things that are like they can have different implementations, like Apollo, Relay, some kind of simple cache. So you can pull those like things that actually manage the data and implement them like in different ways with different trade-offs. So I think that's really and that's the way like we always did it with React, is that instead of adding like applied features that correspond to specific use cases, we try to find what is the primitive that we can add to the component that can empower like everyone to create those specific abstractions that are specific to a use case, like routing, data fetching, and so on, that all benefit from this shared common denominator that React can efficiently manage, a component. And so it's all about empowering and like raising the abstraction level so that like React can coordinate all these components to work together really well. But then you have the freedom to actually do different things from them, depending on like how you implement them. So I think that's like for me, the end game is just that we've made components useful enough that it's easy to create really like compelling user experiences that like don't freeze your browser, that don't flash a lot of spinners, or like don't pop elements one by one, but instead like show you the whole thing. And so they automate making the UI like good UX, and in a way that you could work around it. Like you can do it by yourself manually on a small app, but it's impossible to like orchestrate a large app to just like prepare a beautiful new screen and push it at the right place and so on. And so I think a big part of this is just figuring out the idiomatic solutions, so that instead of coding around it in an ad hoc way and like adding these hacks to make the user experience nicer in like random components, instead this is just how it works by default. And then like if you want a crappy experience, you can opt out of it. So I think that's the end game of React, and we're just trying to find a good base abstraction and then make React smart enough to deliver a great user experience.
Oh, that's so great. I love that that goal there. And one thing that I feel like is a really good takeaway for people who are listening is to like think of Sebastian's example of what you've described is how you stop and you question all the assumptions, and you say, now we make the assumption that this is a problem, and we are assuming that this is the reason that's a problem, but actually it could be this more foundational, fundamental piece. And I think a lot of people, product engineers or library authors or whatever, could benefit from that type of intentional process. When you have a GitHub issue where somebody says, hey, I'm having this problem, I suggest that we add an additional option to opt out of that or something. Like, Dan, you're smiling. This happens all the time. Instead of giving an additional option, maybe there's another primitive that you could expose, or a pattern that you could implement, like inversion of control or some other thing that could empower not only solving their problem, but also eliminate an entire class of problems, which I think is...
And get a new class of problems, which are hopefully not worse.
Yeah, exactly. Always good to keep that in perspective. All right, cool, Dan. This has been so fantastic. Thank you so much for chatting with me again about the future of React and kind of rethinking what are the goals of React here. I think a lot of people are going to appreciate this episode and pull a lot out of it. So I thank you again for giving me your time.
Thank you.
All right, we will see everyone. Well, we won't see everyone, but you'll hear us next week or whenever you listen to the next episode. Thanks. Goodbye.